Good morning to all of you students. Welcome to the mathematics class. In this session, we will study sets. It is an important chapter. So student, first of all, we will discuss what is the definition of set. A well-defined a well-defined collection of all the objects is called set. So it means that if we collect all the objects in a manner way, then it is called a set. For example, the set of days in a week, the set of vowels in an alphabet, the set of natural number less than 10. So these are the example of sets. Now student, set is represented by a symbol. We can donate any set by a symbol, capital letters. So we can represent any set by capital letters, for example A, comma B, comma C, or by represent small a, small b, small c. So these are the notation of set. Now student, representation of set. It is important. Set can be represented by two different ways. And first is listing method or tabular form. And it is also known as roster form or roster method. In this method, we can represent any set as given follows. And first is n. The set of natural number is given as capital N is equal to 1 comma 2 comma 3 comma 4 comma 5 and so on. In the same way, we can represent the set of whole numbers W is 0 1 2 3 4 5 and so on. In the case of integers, we can represent like this: minus infinity to plus infinity. Now the second rule is rule method or set builder form. In this method, we can collect all the elements by the words. For example, A is the set which is given as x such that x is a prime number. That means here x is an element which shows that it is a prime number. Same is in the same way n, x such that x is a natural number, w is equal to x such that x is a whole number. So these are the representation in the set builder form. Now student, there are some symbols which are given for the following sets. For example, if we use n, then it represent a set of all natural numbers. Z, then it represents the set of all integers. Q, the set of all rational numbers. R, the set of real numbers. Z plus set of positive integers. Q plus set of positive rational numbers. R plus set of positive real numbers. And F is the set of all fraction. And Z naught is the set of all non-zero integers. Now student, take some example. First example is write the set of the letter in the word Allahabad. So there are many letters in the Allahabad, but we only use those letters which comes at one times. Means A, L, A, H, A, B, A, D. So A comes different types, different ways, but we take only A one times. So the collection will be A, comma L, comma H, comma B, comma D. This is a well-defined collection. Now the second example is write the sets x such that x is a positive integer and x square is less than 70. So the required numbers are 1, comma 2, comma 3, comma 4, comma 5, 6, 7 and 8. And these are the numbers whose square is less than 70. Now student, we will discuss here types of set. It is also an important topic and it is a subtopic of this chapter. So first set is singleton set. Singleton set means a set containing only one element is called a singleton set. If we take a set and this set contains only one element, then it is called singleton set. For example, 1, 0 and A. All these are the example of singleton set. Now empty set. Empty means no. So if set contain no elements, then it is represented by phi or this bracket, and it is known as empty set. For example, a x such that x is a married bachelor. So no bachelor can be married. That means there will be no element in this set. So it is called empty set. Now finite set. Finite means definite number. If any set contain fixed amount of number, then it is said to be finite set. For example, if we take a class and the number of students in that class is 20, so we can say that this class is a finite set. Equal set. If any two sets are contain same elements which are exactly same in the values, then they are called equal set. For example, if a is equal to 2 comma 5 comma 7 and b is equal to 7 comma 5 comma 2, then they are equal set because they both set contain three elements and the values of these three elements is exactly same, so it is called equal set. Now student, equivalent set. Equivalent means equal in number but not equal in magnitude. So equal set. So here we will discuss two sets. First is a is equal to 1 comma 2 comma 3 and b is equal to a comma b comma c. Here number are same. Three elements in both set but their values are different. So they are called equivalent set. Subsets. If we consider a set A and another set B and all the elements of set B is also the elements of A, then we can say that B is the subset of A. And if all the elements of set B is not the element of A, then B is not the subset of A. For example, A is a set whose elements are 2, 3, 4 and B is another set whose elements are 1, 2, 3, 4. So here all the elements of set A is also the element of B. That means we can say that A is the subset of B. But B is not the subset of A because all the elements of B is not the elements of A. Now there is a most important theorem, and the statement is the empty set is a subset of every set. Empty set is always a subset of every set. The second theorem is every set is the subset of itself. We know that if we consider the same set A, so A is also the subset of A because all the elements of A will be the element of same set. Proper subset. If we consider a set A whose elements are 1, 2, 3 and another set B whose elements are 1, 2, 3, 4, then we can say that A is the proper subset of B because all the elements of A is also the elements of B and at least one element should be in B which is not the element of A. Set of sets. If we consider some sets and collect all the sets and make a collection, then this is called a set of sets. Power set. The collection of all the subsets of a set is called a power set. For example, if we take a set A whose elements are 1, 2, 3 and make all the subsets which are possible. So these are these and make a group, then this group represent a power set. And next is universal set. If we consider a set A whose elements are 1, 2, 3 and another set B whose elements are 2, 3, 4 and these are the elements of a natural number. So here we can say that n is a natural number which contain all the elements of set A and B. Then n is said to be universal set. Universal set means a set which contain different subsets. Next, the number of subsets of a set. It is important topic because There are some questions are related to this topic, and the value of this is 2 to the power n, where n is the number of elements in any set. And if we know a set whose elements are 1 comma 2, that means here number is 2, then we can find the subsets, number of subsets, and the number of subsets will be here 2 to the power 2, that means 4. Subset of real sets of real numbers. So student, learn this line because this line is most important and usually used in the further classes, in the higher classes. So n is the subset of z is the subset of q, and q is the subset of r, t is the subset of r, and n is not a subset of t. So these are the subsets which are related to one another set. Venn diagram. Student, it is a important topic because with the help of Venn diagram we can represent different applications and different operations which are related to the Venn diagram, related to the sets. Here we can represent some sets in the diagram method, so it is called Venn diagram. Here u is equal to Here u is equal to 1, 2, 3, 4, 5 and so on 12. So it is a universal set, and A is another set whose elements are 1, 3, 5, 7, and we can represent this in the diagram method, so it is known as Venn diagram. The given diagram is, this is the required diagram where A is the subset of B, A, B and C are the subset of U, and all the elements are related to U, that means U is the universal set, and A, B, C are the subset of U, which is given as in the figure. Now we will discuss here set operations. There are two main set operations are, first is union of two sets, and second is intersection of two sets. Union means combination. It is given as A union B is equal to X such that X and X belongs to A or X belongs to B. Then union of A and B is given the collection of all those elements which are related to A and B. By the diagram method, we can represent it. Here, the shaded part of A and B shows a union of A and B. In the third diagram, A and B both are the elements, but there is no common, there is no addition in both the elements. That means it is not a union of A and B. For example, if we consider two sets A and B where elements are A 1, 2, 3 and B 2, 3, 4, then union of A and B will be 1, 2, 3, 4. The same way, if we consider another example, then union will be 3, 6, 9, 12, 15. Now, the laws of union sets. There are some laws of union sets. First is idempotent law, means A union A is always the same set. Second is commutative law, A union B is equal to B union A. Third is associative law, A union B union C is equal to A union B in bracket union C. And third is identity law. Identity law means always comes the same value, A union phi is equal to A, where phi is a empty set. Hello student, now we will discuss here intersection of two sets. Intersection means common. If we consider two sets and some elements are common in both two sets, then it is said to be intersection of two sets. We can understand by the figure here, the shaded part shows the common of both two sets, so it is the intersection of two sets. And in the second diagram there is no common, that means here the intersection is 0, means phi. Phi means no elements. Now discuss some examples. Find A union B and A intersection B, given as A is equal to 1, 3, 5, 7, 8 and B is equal to 5, 7, 9 and 11. The union of two elements means addition of all the elements is 1, 3, 5, 7, 8, 9, 11. In the same way, intersection will be 5, 7. Now take another example. A union C is equal to 1, 2, 3, 4 and 4, 5, 6, 7. So union means addition. So we add all the elements means 1, 2, 3, 4, 5 and 6. And if we find the intersection of A union B and A union C, so it will be 1, 2, 3, 4, 5, 6. Now take another example. If A is equal to 1, 2, 3, B is equal to 2, 3, 4 and C is equal to 3, 4, 5, 6. Then find A minus B minus C. Here A minus B means rest element of A. So first of all we will find B minus C, which is 2, because B is 2, 3, 4 and C is 3, 4, 5, 6. So rest element of B will be 2. In the same way A minus B minus C will be 1, 3 and A minus B is equal to 1. So we can find the values of A minus B in bracket minus C is equal to 1. Student, by the same method we can find the complement of any set, the intersection of any set, the union of any set, and we can also find these values by the Venn diagram. So practice very well and do all the questions which are related to the exercise. Thank you very much.